So this one's clearly different. The function just looks different in general than the last one, right? Okay?
Couldn't you just like factor it? Or...
You're on the right track. Okay? We'd really like it to look like this, won't we? We'd like it to look like this. Okay? Well, this right here is really not a whole lot different than the one on the next slide. Because if I were to square x plus 2, I'd be taking x plus 2 times x plus 2, and that'd give me x squared plus 4x plus 4. If I FOILed it out, right? X squared plus 4x plus 4, you guys with me? If I FOILed this, and what would I get if I FOILed this? Y squared minus 2y, negative 1 times negative 1, plus 1. Okay? So y squared minus 2y plus 1. So, if I FOILed this out, it would look similar to this, kind of, right? Okay? So, but this isn't very friendly. It's not very helpful. It's not very easy to graph. So if we can make this look like the previous slide, then we can graph it a lot easier. So we got to be able to factor this, because if we took the previous one and FOILed it out, we'd get something that looks like this. So why don't we just work backwards, take this one, and try to factor it? Well, you might have noticed, when I FOILed this out, I had x squared plus 4x plus 4. I had 3 terms there, right? A trinomial, 3 terms. So I would need 3 terms to factor it to something like this. Good old algebra 2, completing the square, making something become a perfect square. You might have recalled something, I know that's what I always did anyway. Remember this plus blank? Ever? Hopefully? Maybe not? Okay? Basically what we're going to do is we're going to add some numbers to make these become perfect squares. Okay? What I do is I use this 4, I cut it in half, so 2, and square it, and I get 4. So then, if I took this part right here, and I factored it, what would I have? X minus 2, x minus 2, right? X minus 2, x minus 2. Or in other words, x minus 2 quantity squared. Alright, well now we're getting somewhere. We're starting to make this look like that previous slide. We're completing the square. But now hold on here. Why? I can just randomly add an extra number here? Just do it to the other side. Yeah, good. Yes, I can randomly add a number to one side of the equal sign as long as I do it to the other side. Okay? So if I add 4 to this side of the equal sign, just make sure you add 4 to the other side of the equal sign. Okay? How about this number right here, this blank right here? 16. How'd you get that? Cut 8 in half and square it. Take that linear term, the b value, a squared plus, or ax squared plus bx plus c, the b value, okay, cut that in half, 4, square it, you get 16. If I add 16 to this side, I better add 16 to this side. Now if you look at just this part right here, and you factored it, what would you have?
For y squared,
Y plus 4, y plus 4. Okay? Or in other words, y plus 4 quantity squared. And that equals 16 plus 4 is 20, plus 16 would be 36. Does that look like it's a circle you'd be much more willing and able to graph? Where's the center? 2, negative 4. And what's my radius? 6. Good job. I'm not going to graph it. You guys can draw circles. Center would be at 2, negative 4, my radius would be 6. Okay? Thoughts on that? Alright, I'm going to give you one of these then, next. I guess I can probably stop the video.